Welcome to The Explainer. We're getting right under the hood today, tracing an absolutely incredible journey. We're going from a quiet, free research preview back in late 2022, one that accidentally broke the internet and became the fastest growing consumer application in history, all the way to the incredibly powerful developer APIs we have today. If you've ever wondered how we got from those early conversational models to the massive scale and multimodal capabilities of things like GPT 5.5 and what that actually means for building software right now, well, you are in exactly the right place. Let's dive into this.
Here's what we're covering today. We'll look at the big November 2022 release, how RLHF trained ChatGPT, some known limitations, the iterative deployment strategy, what developers absolutely must know, and finally, the evolution to modern APIs. Let's jump right in.
Section 1, the November 2022 release. Let's start with the milestone that literally shifted the entire tech landscape.
You know, that massive November 30th drop wasn't actually some heavily marketed commercial product. It was literally just a staged research preview. And here's the wild part. The underlying model, the GPT 3.5 series, had already quietly finished training months earlier in early 2022 on these massive Azure AI supercomputers. It was kind of just sitting there. ChatGPT was essentially a sibling model to InstructGPT. It used that same core lineage, but OpenAI deliberately tweaked it for multi-turn conversations. They basically wanted a model that wouldn't forget what you said 5 minutes ago in a chat thread, rather than treating every single prompt like a brand new isolated task.
Section 2. How RLHF trained ChatGPT. So what exactly made this sibling model so exceptionally good at dialogue? To get the model to do things like admit mistakes or politely challenge your incorrect premises, OpenAI utilized RLFH, which stands for Reinforcement Learning from Human Feedback. Think about it like this. A base language model is essentially a raw autocomplete engine, right? It just desperately wants to predict the next word, even if that word leads to a toxic or totally unhelpful tangent. RLFH fundamentally alters the game. If the base training is like teaching an actor how to speak the language, RLFH is like handing them a specific script, a polite persona, and a director who tells them exactly how to interact with the audience. These conversational skills weren't just happy accidents, they were highly engineered. The mechanics involved this really fascinating two-step process. First, human AI trainers literally sat down and role-played both sides of a conversation. They played the frustrated user and the endlessly helpful AI assistant. I mean, just picture the pure comedy of an engineer sitting at a desk, talking to themselves all day in a chat window just to create an initial behavioral baseline for a neural network. They did have model-written suggestions to help them move faster, though. Then, for step 2, this new dataset was mixed with older ones to train a reward model. That reward model acted like an automated judge, steering the reinforcement learning process to consistently spit out the exact kind of conversational outputs that human raters preferred. Section 3, no limitations and quirks, because, let's be honest, as groundbreaking as this was, it definitely wasn't perfect. OpenAI was actually pretty upfront about the model's structural limitations right out of the gate. For one, the system would write these incredibly plausible-sounding, but completely incorrect answers. We've all experienced that firsthand, right? When the AI just confidently hallucinates a fake fact. It was also notoriously sensitive to exactly how a prompt was framed. Rephrase your question just a little bit and boom, totally different response. It forced all of us to become prompt engineers practically overnight. It was often super wordy, and depending on how cleverly you framed a prompt, it might actually respond to harmful instructions instead of refusing them. Plus, thanks to that early 2022 training cutoff, it had zero real-time internet awareness. Ask it about yesterday's game and it was clueless. Section 4, iterative deployment strategy. Now, a natural question comes up here. Why on earth release a model with all these known quirks to the general public? Well, OpenAI intentionally released these models early, at controlled stages, rather than waiting for some flawless, perfect production threshold. They called this strategy iterative deployment, and the reason makes a lot of sense. The real world is essentially the Wild West. Real users trying to do real-world tasks will expose failure modes, complex edge cases, and completely unhinged jailbreak attempts way faster than any controlled internal red teaming ever could. A room full of brilliant engineers in a lab just can't anticipate what millions of teenagers, developers, and writers are going to throw at a chat box. Calling it a research preview was entirely about gathering this massive real-world signal to inform future safety work. Section 5, what developers must know. All right, let's pivot to the practical reality for builders and see how this impacts modern AI development. There is a massive, incredibly important difference between the consumer product and the API. A lot of developers get totally burned here because they assume the API is going to act exactly like the website out of the box. Spoiler alert, it doesn't. That smooth, multi-turn coherence and eagerness to revise answers that you see on ChatGPT.com, that's a fine-tuned behavior wrapped in a specific web application. If you just ping the underlying base models through the API without building your own prompting structure, managing the conversational memory yourself, and setting up strict system instructions, you are not going to automatically get that same conversational magic. They are completely distinct entities with different rate limits, pricing models, and update cadences. This next concept is absolutely vital if you're building AI applications today. Because RLHF shapes the model's ability to safely decline a harmful request, it does so probabilistically. To really get this, think of a probabilistic refusal like a bouncer at a club. The bouncer usually keeps the bad actors out, sure, but if someone wears the right disguise or uses a clever excuse, the bouncer might accidentally let them slip by. It is not a strict, rule-based filter, which would be more like a locked steel door. Because the model is still sensitive to prompt framing, you can't just cross your fingers and rely on the AI's internal training to catch everything. You literally have to layer your own separate, strict moderation tools and guardrails on top of the model output to guarantee your application is safe. Section 6. Evolution to modern APIs. Fast forward from that 2022 historical foundation to right now, and the developer ecosystem has scaled massively. Today's flagship model for complex reasoning and coding is GPT 5.5, and it can handle a staggering 1 million token context window. To put that into perspective, 1 million tokens means you can drop multiple dense textbooks, hours of video transcripts, or your entire software codebase into a single prompt, and it analyzes the whole shebang at once. It's wild. If you're optimizing for speed and cost, options like GPT 5.4 Mini bring the price down to just 75 cents per million input tokens. Plus, these models now feature native, specialized tool calling capabilities. They can execute code, search files, features that absolutely dwarf what that original research preview could do. And programmatic access isn't just about text anymore. The sheer speed of this advancement is honestly mind-blowing. We now have specialized real-time APIs designed for instantaneous voice translation with GPT Real-Time Translate. We've got streaming voice interactions with incredibly low latency through GPT Real-Time 2. We have state-of-the-art image generation through GPT Image 2 and real-time transcription via GPT Real-Time Whisper. Going from a simple text-only chat box in late 2022 to a full suite of real-time multimodal developer tools that can see, hear, and speak in just a couple of years, that is a phenomenal leap in computing history. Which brings us to our final thought. We've seen exactly how these models evolved from that initial RLHF training, and we know that underneath it all, their core guardrails and behaviors are fundamentally probabilistic. So the ultimate question for you as developers looking at this massive catalog of AI power today is this. How are you going to engineer your own safety nets and prompts to unleash the massive raw power of frontier models like GPT 5.5 without letting them run off the rails? Think about it. Thank you for joining me for this explainer, and happy building.